In the last video, we have talked about the binary and ternary number system. In this video, we are going to talk about another number system, the hexadecimal number system. The hexadecimal number system is a base 16 number system. Here we can see that the number 1234 in the ternary system is 4D2 in the hexadecimal system. Since the hexadecimal number system is a base 16 number system, it needs 16 different digits. Besides the number 0 to 9, we need 6 more digits, so we use the letter A to F. A means 10, B means 11, and so on. So we can see that the D in the second digit means 13. This is the chart that shows the corresponding representation in different number systems. So let's look at how to convert between different number systems. First, let's look at how to convert from binary to hexadecimal. First, we split the digits into groups of 4 from the lowest digit, and then we find out the corresponding representation of each group. Take the last group for example. 1011 means B in hexadecimal, so we can get the hexadecimal representation. By the same way, we can convert every digit in the hexadecimal representation into 4 digits in binary. For example, 6 in hexadecimal means 0110 in binary. So we can get the binary representation by changing every digit in the hexadecimal number system by 4 digits in binary. Then we are going to find out how to convert between ternary and hexadecimal. The method is similar to the method we used to convert between ternary and binary. To convert from ternary to hexadecimal, we take each digit and multiply it by the heading values. For example, we multiply 4 to its heading value 16 to the power of 2, which is 256. D, which is 13 to its heading value 16 to the power of 1, and 2 to its heading value 16 to the power of 0, and add them together. And then we can get the ternary representation 1234. And to convert from hexadecimal to ternary, we divide the number by 16 until the value 0 is reached, and we will look at the remainder. Take 2847 for example. First, we divide 2847 by 16 and we get the quotient 177 and the remainder 15. And then we divide the number 177 by 16 and get the quotient 11 and the remainder 1. And then we divide the number 11 by 16 and get the quotient 0 and the remainder 11. Since the value 0 is reached, we will look at the remainder. Remember that the first remainder we get should be placed at the lowest digit, and the last remainder should be at the highest digit. And we can get the hexadecimal representation of the number 2847, which is B1F in hexadecimal. In the next part, we are going to look at some usage of the hexadecimal system. The first example is the error codes. We use hexadecimal system to represent the error code number. You can see that the error busy drive is represented by 0x8e, where the 0x in the front means the number is represented by the hexadecimal number system. Each error code has its own error code number. The second example is the media access control address. The MAC address refers to a number which uniquely identifies a device on a network, and the address is rarely changed. The MAC address is usually made up of 48 bits, which are shown as 6 groups of 2 hexadecimal digits. The first half is the identity number of the manufacturer of the device, and the second half is the serial number of the device. The third example is the Internet Protocol address. Each device connected to a network is given an address, known as the Internet Protocol address. An IPv4 address is a 32-bit number written in ternary or hexadecimal form. IPv4 has recently been improved upon by the adoption of IPv6. An IPv6 address is a 128-bit number broken down into 16-bit chunks, represented by a hexadecimal number. The last example is the hypertext markup language color code. Hypertext markup language is used when writing and developing web pages. All colors can be made up of different combinations of the three primary colors: red, green, and blue. Each color is determined by its hexadecimal value. For example, B38A01 represents this color. In the HTML code, the color code are always 6 hexadecimal digits representing the red, green, and blue components. There are 256 possible values for the red, green, and blue color, giving a total of 256 times 256 times 256 possible colors. So what we have learned in this video is the hexadecimal number systems, the conversion between hexadecimal and binary, and the conversion between hexadecimal and ternary, and also the use of the hexadecimal system. In the next video, we're going to talk about the arithmetic operations of binary numbers.